What's going on, guys? It's Ben from Pragmatic Software Engineering, and today we're going to be talking about another object-oriented fundamental called interfaces. Now, what is an interface? Well, an interface is a really great tool we have to enforce contracts between pieces of code. Now, what do I mean by contract? Well, a contract, it doesn't really have a formal definition that I can think of in programming, but it basically means two things agree on what I put in and what I get out. We've agreed upon what the structure of the contract looks like. Now you can use this to do whatever you'd like. So here we have some Googling terms if you want to do some more extended research on your own time. You could Google interface, which is what we're going to talk about today, or you could Google implementation. Again, I'm going to belabor this point. A class represents a concept or a noun in English. Interfaces are a contract for an implementation. So an implementation is kind of like the instantiation of an interface or contract. So as an example, we have a USB device here, a nice little USB plug. And a USB device is an interface that we can represent, where a webcam can be a USB device, and so can a phone charger. But obviously, when you plug in a phone charger, it's transferring power and maybe files, and a webcam is transferring information that is basically, pictures or video. So when you create an interface, you describe it by using the functions that contract upholds. And these functions work exactly like abstract methods. So when you create an interface and you implement an interface, or you create a class that implements an interface, you have to actually write how that function works. Interfaces work a little bit differently from abstract classes. So for one, you can actually create a class that implements multiple interfaces. We won't do that today as an example because that's more of an advanced usage of interfaces, but it's similar to saying this class supports multiple contracts. Similar to how we worked with the write function in the previous video for fountain pens, you have to use an override annotation and provide your own implementation in Java. Interfaces can come with default methods, which are basically an implementation already out of the box for the interface. This is a little bit strange, and it kind of goes against the idea of an interface, but it is still possible in Java. There is a whole cornucopia of benefits you can get from using an interface. For one, once you're upholding a contract, now you can actually have the flexibility of what to do in that contract. Additionally, it makes things a lot more testable because you have a contract that you know is there and you can easily test that contract. It allows you to, as you create more implementations of that interface, to plug and play with your code. And this is something we'll be talking about more, and the idea of software testing and actual development acceleration. It allows you to make your development of your application or your code independent of another party. That's something I really can't wait to talk about, but it's not something we're going to talk about today. And it also helps us with polymorphism, which is going to be coming very soon to a theater near you. So yes, interfaces are really cool, but you want to make sure that you don't overuse them. So don't create an interface for every class that you use just because you want to document that contract. Only use that interface, or only create an interface if you think that multiple classes are sharing in a contract. So let's create this idea of USB devices in Java. I've created this little class here called a connection, which provides power and provides data transfer as integers. This is just a useless class that I'm using just to make this a little bit more readable. So let's create a webcam. And what the webcam will do is when it is connected, it will send data. And now let's also create a phone charger here. Same thing. Phone charger. And a phone charger, all it does is uses power to charge the phone. So if we were going to create a interface called a USB device, you see here it's a public interface, not a public class. It's not a class, it's an interface. And what you can do is you can say, you can have some sort of function that says public on connect. So when we connect and we have a connection, we can do something. So now we've created an interface here called USB device, and we have said there is a actually this public might not be even needed. It isn't even needed. Excuse me. This anything that is a USB device must have an implementation for OnConnect. We're going to now turn our webcam into a USB device, and instead of using the extends keyword, we're going to use the word implements. USB device. Always try to use your IDE to the best of its abilities to write the code for you. And now we have an OnConnect, and we actually provided a connection in this function here. And if you wanted to, you could do whatever you'd like with that connection. In this case, we're going to be using the power. We'll be using the data transfer, right? So now we have a webcam that is powered by the USB, or at least we have code that pretends like it is. If we go to the phone charger, we can do implements USB device again, and what we can do is use the power here. So let me split my IDE. Okay, now you can see the phone charger and you can see the webcam. And let's get rid of this. So you can see we have two USB devices here, and they both override this OnConnect function and do something with the connection, but they're not doing the same thing. This is different from an abstract class because, hey, look, they're using different functions in it, but they still both have this sort of contract where they do something when we connect a connection. So in conclusion, interfaces are an excellent way for us to write code that can depend on outputs and inputs and things like that, but you actually can specify how the work is done underneath. You can describe contracts between code without actually sharing the code. This is a really powerful tool, and as you grow as a software engineer, you'll probably find you'll use interfaces more often than abstract classes.